Alright, so I got my son here. He's going to take apart this direct drum. So you're going to go ahead and take the big snap ring out to get the pressure plate out. He's just going to use a screwdriver to pull that snap ring apart. Then you can either pull them out individually or you can flip the drum over. He's going to flip it. That stuff's out. Get the last couple out. And the wave plate. There you go. So now we gotta take this over to the press and we'll press this down and get the snap ring out to get the piston out. Okay, so I got the direct drum here. I just have it in the press. This is just a piece of 3-inch stainless tubing, like exhaust tubing. Cut that into a U shape and open up the snap ring, hook it with the screwdriver, pop the snap ring off, and you can just loosen up the press. And the spring pack comes out. So next he's going to take out this spring pack, and then we'll go ahead and pull the piston out. Then he's going to go ahead and take this center seal out on the drum. There's a little lip seal in there, so that's got to come out. Just jam that bad boy out and then probably grab it with your fingers and pull it out. Grab it with your other hand. Like this. There you go. Now you can pull it out. Alright. So yeah, we can pull that thing out, and then now we're going to drill a hole in here. So that should be done except for the drilling. And then what I like to do is like to use the machine spot here to drill through. So there's usually 2 machine spots for balancing, and then I usually drill through that machine section because it just has less material where it's machined. So we'll do that next. Alright, now we got a 60 thousandths drill bit on there, and he's just going to go real careful. Not put a lot of pressure on the drill. There you go. Pull it back out.
That scared me when it went through.
Yep, it's a little unexpected, but now we got the hole there, so we'll do a good job cleaning those metal shavings out of it.
Like this.
Don't do that. So the purpose of this is if you have residual fluid inside of this, as this drum starts to spin really fast, it will push on the back side of the piston and it will start to apply the piston and drag the clutches. So this is just like an extra relief hole. You put better springs in it. Springs push the piston back, and as it spins it will let all that extra fluid come out so you don't drag the clutches. And the piston that's going to go in here has a check ball. The drum has a check ball. Check ball in both is okay. No check ball is not okay. So you want to have at least 1 check ball in one or the other. But 2 is okay, 0 is not okay. Okay, so we got the new aluminum piston here. Got the center sealing ring, lip seal out of there. Got the hole drilled and all of the metal dust cleaned out of there. I'm going to test fit this thing just with no lip seals on it, just for the sake of sliding it in and out, moving it around, not messing with the lip seals. So what I'm just going to do right away is go ahead and just put the forward steels in there. And I know this will be good, but just for good measure we'll test it just to make sure that we don't have any issue with this thing spinning. This is the one that's machined too far, and the steels actually spin inside the drum. And then I'll go ahead and drop the rest of the forwards in there. And right now I'm just going to be checking clearances. So I'm not worried about alternating the clutches and steels at this point, because this isn't going to be final assembly. I'm just going to be checking them like that, and I'll take my 6 Borg clutches and I'll put 1 steel on top, just so I can put the gauge, feeler gauge, in between the steel and the pressure plate. Because I get paranoid sometimes about trying to jam these feeler gauges in there and then it like scuffing the clutch. So now what I can do is I could stuff this thing in between the steel and the pressure plate, and I can move it around like this to test the clearance, and I don't have to worry about scuffing the clutch or scratching it or doing anything weird to it. There we go. Oh, that was a little tough to get in there. I mean, it slides in, it was okay, it's just trying to get the right angle to get the thing to go in. There we go. So now we have a 30 and a 32 stacked up, and that's actually okay. It's in there snug, but it fits. It's not in there like super duper tight, but it fits, and it's not super loose either. And I don't know why, but I usually just like to grab like this and move it around, make sure I got good free play in there and actually feel some movement. Because when the forward drum is engaged inside these clutches, this is actually spinning the opposite direction. So the forward and the direct drum are actually spinning opposite direction of each other. So these clutches in here are free spinning opposite direction of the drum at, 8, 9, 10, 11,000 RPM. And that should be able to allow for fluid to get in between the clutch and the steel also. So that's okay. No more clearancing needed. Now I'm going to go ahead and I'm going to pop this spring retainer apart and put the stiffer springs in there. All right, so I just inserted all of these springs. These are actually a stiffer set of springs. I believe these are from an HD2 kit. A lot of the trans brake kits will come with springs. The Jake's kit comes with springs. Extreme Automatics comes with springs. And they're stiffer, so it just provides a quicker release of the piston. It releases the clutches quicker. So I usually just use a flathead and kind of walk it around and start pushing the springs off. You can see the springs coming off the plate there. And then you're also going to remove the spring from the top, which can be a little bit more tricky. There, now we got that one off. So I have all the springs. I'm going to remove this whole top plate and then I'll come back. But basically just using a flathead and prying the springs off the plate. Alright, so now you can see that these little holder areas are kind of mushroomed out, and they'll actually grab the spring a little bit, so you can kind of, well, that one keeps falling off, but you can kind of put them on where they need to be, twist them a little bit, and then they'll kind of hold them in place. So I'm going to go around and I'll put all of them on, then we can work on putting them in the piston. All right, a lot of these are actually falling off, so I'm going to end up doing it this way, putting them in the piston first, and then I'll flip it over and get them lined up. Then I'll just go ahead and look inside all the holes and then make sure the springs are actually lined up around that little mushroomed area. Then we can compress it and put the snap ring on. And I didn't mention it earlier, but do the clearance measurements with the spring pack out of it. It'll be a lot easier than trying to jam a feeler gauge in like this with the springs in the way. I didn't mention it, but figured I would say something. I'm so excited to put that spring pack in that I never put the lip seals on the piston. So I'm going to go ahead and do that now. Just put some assembly lube on it. And there's a couple different kinds of seals, and the kit comes with like extra stuff. So make sure the lip is on the inside on this one. And don't actually put the lip inside the piston. There you go. So make sure that lip is on the inside, and then do the same thing with the outer lip seal. So you can see this one kind of has like a flat rectangular edge there, and then this one actually has the lip on the outside of it. Put some assembly lube on it, and then stretch this thing on all the way around. And then I just want to make sure enough assembly lube is on there, because it can be kind of hard to get inside the drum when you put it in. So make sure that's lubricated nicely. Same thing with the actual inner lip of the drum. Go ahead and throw some assembly lube there. This is a fresh seal, so it might be a little bit challenging to get down. So we're gonna make sure we don't catch on the inner seal. You want to accidentally fold that thing over. Alright, so now that's down over the center. And then we gotta apply a little bit of downward pressure. And then I usually just go around the outside with a feeler gauge. I try to use one that's thick enough. I'm using a 16th thou right now, but I try to use one thick enough that it's not gonna cut the lip seal easily. There is actually a tool for doing this. It's called a lip wizard. It's a green tool. It's like 16 bucks. So if you want to be the lip wizard, you can do that free of charge, plus $16. And you can actually kind of see where the lip seal is actually stuck up on that edge. You can kind of push it in. There you go. Now it'll fall in. All of the springs lined up in the holes. I have it over on the press, and I'm just going to press this plate down. And make sure I get it down past the snap ring groove. And then usually what I do is I put the opening towards me and use my thumbs and just push it over like that. I can release the springs and it'll hold. Alright, so now what I'll do is I'll get the snap ring back off and open it back up, take the clutches and steels out, and I'll start to soak the clutches. And then while those are soaking, what I'm going to do is I'm going to take this spiral lock snap ring off, and then we'll check the sprag. So if the drum is upside down, this will spin clockwise, and it will not spin counterclockwise. See how it catches the drum? So it freewheels clockwise, but not counterclockwise. So this is the right way. Clockwise, locks counterclockwise. You can actually put that in backwards, and that'll cause you issues. So this is a spiral lock snap ring, and then this plate comes off, and then you can pull this whole thing out and your sprag comes out. But I'm just going to remember which way that it was in there, and then really what I'm going to be looking for here is just that there's no noticeable damage on this race. Make sure that's nice and smooth all the way around. There are some little marks on it, but I can't feel them, so it's still smooth. This can actually get damaged and get like little divots and grooves in it from the sprag locking so hard on it. Because when this is in the transmission, as I said, it's spinning the opposite direction while you're in first gear, and then when you go to do the 1-2 shift, it locks this drum and stops the drum and starts spinning it the other direction. So this thing will be spinning. These teeth sit inside your intermediate clutches. So when your intermediate clutches apply, it locks the sprag and stops the drum. So it's using this sprag to stop the drum. So you got 10,000 RPM to a dead stop, and that's all it uses is this sprag to do that. So you have a lot of weight on this drum, a lot of rotating mass, and comes to a complete stop. So that's where you can actually break that sprag or roll that sprag, or you can divot these things and damage these. If you guys have been around for a little while, remember the Mustang that I built, the Turbo 400 that was in that? The new owner did like a 8,600 RPM 1-2 shift. It was like on rev limiter. It was a really high RPM shift, and it actually broke the sprag.
So the pieces are just falling out of the inner, or if it was already like that. So you can see these are coming out.
Like basically destroyed the sprag. Didn't have second gear. Didn't hurt anything else in the trans. It did put some divots in the drum. Broke the sprag. But he had it, back together a few days later because it didn't wreck anything else. But that's kind of what can happen with that, and that's why like high RPM or really high power builds will use an aluminum drum because you have less rotating mass, and then they'll use a 36 element sprag instead of the 34 element sprag because you have a little more holding power and it's stopping a lighter drum. Alright, so I feel okay about it. I'm going to put it all back together. You have one of these little race pieces that goes around the inner race, and then you also have one on the top of the sprag here. So that goes on top, and then usually you can just put this thing over the top and kind of rock it, wiggle it back and forth, and then twist and push down on it, and it'll go back in. Make sure that it is on the right direction and locks the right way. Put the plate back on, put the spiral snap ring back on, then we're good. Just walk this thing all the way around. Make sure it doesn't flatten the groove all the way. And another thing to add is the spiral lock snap ring also helps with how fast the drum is spinning. So if you had an open-ended snap ring like this and the thing is spinning at 11,000 RPM, you're going to have centrifugal force pulling the snap ring open like this as it's spinning. So that could actually release this, and you wouldn't want that to happen. So the spiral lock prevents it from opening up like that. And the top of the drum also has these little locking tabs in there. So once this is up, if it did start to open up, it wouldn't be able to open up enough to actually come loose. Alright, so I got my 6 clutches and my 6 steels. Not doing a wave plate in here, so we're just going to put the steel down first, clutch, and then alternate the whole way through. And I haven't figured out a way to like do this gracefully yet and make it look smooth. Oh, that one went in nice. Swoosh. All right. So there's 6 of them in there, alternating. Put the pressure plate on. Put the snap ring on. And then we are done. All right, now I can go ahead and drop this drum in there. I mean, don't actually drop it, but I can give her a little twist. Ooh, that went in nice. Make sure we got metal on metal. It's all the way down. And now we can move on. Next is a forward drum. I'll be doing 6 clutches also in the forward and rollerizing the front hub. I got a Sonex rollerized front hub for that thing. And that'll be the next video.